Hi all, this is the video for 8.4. We're going to be looking more closely at passive movement of sprites in Pygame. So for this demo, I'm not actually going to type any of the code out. I'm just going to show you the code that I've already written, do some explaining. And since this is in video form, you can feel free to go back and rewatch as needed, or maybe even code along for the assignment as you watch the video, whatever's most helpful for you. To start off, I'm going to run the program so that you can see what kinds of passive movement I'm talking about. So first you'll see that tree that's kind of going to the edge of the screen, then reappearing at the other side. I'm calling that scrolling movement. Then we've got our turtle with wings. That's definitely not a ripoff of a Mario game. Going up and down. And once it hits a certain point, and we're going to call pacing movement. And then you might see that little black dot with the wings. That's going to be our fly that's moving kind of randomly. And you'll notice that sometimes he's going off the screen. If you want to prevent that, I did give you a tutorial for how to do that from a previous lesson, but we're not going to worry about that for this one. You can incorporate it into your own work if you would like to. So I have 3 sprites that I've made for each of these different kinds of movement. And before I forget, I'm going to turn code intelligence off so that these pop-ups don't keep blocking your view. All right, so the first sprite is the turtle sprite, that's moving up and down, that pacing movement. And you'll notice that the init function looks a lot like the ones that we explored in the previous lesson. We've got a surface, we've got an image, the rectangle, velocity. My X and Y coordinates are optional, but this is how you start a sprite at a certain location on the screen. And then I've added for this specific type of movement an additional variable called direction. And that's going to help me keep track of, is my turtle moving upwards or downwards? Negative being up, positive being down. And if you wanted your sprite to pace side to side, it would be the same concept, except negative would be to the left, positive would be to the right. So I'm going to demo this for vertical pacing movement, but you can absolutely adapt this for horizontal movement should you choose. And then let's look at our move function. So I have a couple of things going on, right? I'm going to run the code again so we can visualize this as we're looking at the code itself. So if my Y coordinate for my turtle is less than 10, meaning my turtle is way up here, that's when it hits this point, I want my turtle to bounce back. So I'm going to change the direction using line 18. So if it was formerly moving up, now it's going to move down. I'm multiplying it by -1 to make that negative into a positive. And then I'll start that sprite back at Y equals 10, so that if I went a little bit past it, because this math is not going to be perfect because there's a lot going on in this game. If I've gone past the Y equals 10 mark, then I'm going to start back at 10 and then head back down. Just to make it a little bit easier to visualize, I'm going to go ahead and draw out our axes here. So this is the Y axis, and this is 0. And if I look, the size of my screen is 300. So I'm going to put 300 here. And then similar for X, this is my X axis. 0 is here, 400 is here. So hopefully this helps you visualize that if my sprite is moving in a negative direction on the Y axis, it's going this way. The number is getting smaller. If my sprite is moving in a positive direction on the Y axis, it's moving down. That Y value is getting bigger. Let me do that. And let's go back and look at the code. So also I'm having some internet issues here, so hopefully we'll see it come back in a sec. So if we hit the top, if we hit that spot where I want to turn around, change the direction. But then if I hit the spot in the other way, so if I hit 150 or I go a little bit past that, I also want to change directions. And this 10 and 150 are completely arbitrary. You can make those whatever numbers you want. I just wanted my turtle to pace back and forth for most of the screen. You can try out different numbers in your own code and see how that changes the movement. So I have an if, so if I hit the top, start going down. If I hit the bottom, start going up. And then I have my else. So if I'm not at one of those end caps and I just want to move, then I'm going to change my y value based on whatever my direction is, which is either going to be -1 or +1. So this else is what's going to happen most of the time. And then whenever my sprite hits one of those endpoints, either the if or the elif will be triggered. And just like in our last lesson on the sprites, this function gets called inside of my game loop, my while loop. So this is a.move here. And I'm also drawing my a sprite here. So I move it accordingly, and then I draw it, move it, draw it. And that happens repeatedly. If you want the sprite to move faster, you can make this number bigger, not smaller, because we saw the other day that it doesn't take decimal numbers. But if I made this like an 8 and I run it again, my turtle is going to move very, very fast. I clear my drawings, and then let's flip back over and watch it. Moving a lot faster. I'm going to keep it at 1 for now, but just know that you can adapt that as well. Everything here is able to be customized. And that is the pacing movement. So I'm going to collapse this class, and now let's take a look at our second sprite, which is that tree that's happening in the background there. Init looks much the same. No new variables here. I am starting my tree at 100 -40. That way it's further down and it looks like it's kind of on the ground. But aside from that, this is the init function that we saw from the last lesson. And then my move is a lot simpler for this one because there's not 2 places to check, right? There's not a top and a bottom. If we look at the movement, it's moving to the left until we hit the edge of the screen, and then it's starting back over on the right side. And that's exactly what this code does. So every time this move method is called, I want to move my tree 10 pixels to the left. So that's this x minus equals 10. If my x position is at -300, so I've made it off the screen, I'm over here somewhere, then I want to set it back to 300, which is on the other side of the screen. So the movement is pretty regular. It's that -10 until I hit this point, and then I send it back over. And this gives the tree the appearance that it's scrolling, that the background is scrolling along with it. And you can make several background sprites this way and make it look kind of like one of those Super Mario games where instead of the player moving, the background is what's moving. And again, I have my sprite here, my sprite B, and then I'm calling the move function and drawing it here. So in this way of organizing things, the only things that are in my loop are the drawing things, my updating, and calling functions. Everything that has to do with my sprites is up here, so it's easier to find. If you wanted this to have something scroll in the vertical direction, so if you're making like a platformer game, you can substitute X for Y. So that's our second sprite, doing the scrolling movement. Our third sprite, which I think has disappeared by now, it's gone off screen, is the little black fly that's just kind of randomly buzzing around the screen. And so looking at init, most of it's the same. I did add a counter here. And the purpose of this counter is to keep track of how often I want my fly to change directions. So looking at the move function, I add 1 to my counter every time. And I'm going to change my X and Y by the velocity. So I'm going to move my sprite. Once my counter gets to 10, so once I've called this function 10 times, I want to change the direction that my fly is going in. So I'll set the counter back to 0 so that I won't change directions again until another 10 times. And then I'm setting my velocity to something between -5 and 5. I'm including negatives and positives here because I want to include both left and right and up and down motion. If I have it like from 0 to 5 or 1 to 5, it's only ever going to move in this direction. And I want it to look very random. So that's going to include negatives on both ends. If you want it to change direction less often, you can make this number bigger. So like if I make this a 20, let's see if we can tell the difference here. My fly has much more of a gliding motion. It's not changing direction as often. If you want it to move quicker, you can make that number smaller. So now we're changing direction a lot less often. I like the way 10 looks, so I'm going to keep it there. This is also similar to the code that you would use if you wanted to have something bouncing around the screen. You would just add in that extra code to keep track of where the barriers are and only change direction once you hit one of the barriers. We'll look more at collision with other items or other sprites in another video. Oh, I'll show you the move is also here for this one, but that part's pretty much the same. And that's it for this video. I hope that you found this helpful, and you can go ahead and get started on your 8.4 assignment, where I'm going to ask you to use these 3 kinds of movement in order to replicate a scene.